Hi, welcome to Fluid Mechanic. Today we have a question which is water flow at a uniform velocity of 3 meter per second into a nozzle that reduced the diameter from 100 millimeter to 20 millimeter as shown in the figure there. Calculate the water velocity leaving the nozzle and the flow rates. So the first step, what we need to do is we need to analyze the question. What the question asks to determine the water leaving velocity, which is the velocity at the outlet. We consider here as point number 2 as the outlet and point number 1 as the inlet. And then the question asks, find the flow rate. Here is the flow rate of the water, which is the volume flow rate. Thus, in order for us to analyze further, alright, the control volume is selected to be inside the nozzle. So here we have the control volume selected inside the nozzle. In the control volume, we have two components. We have the control surface and control volume. Inside here is the control volume and outside here is the control surface. The surface covering the control volume. Alright. Previously we learned about the Renault transport theorem. So this case, we actually convert from the system to the control volume system. So the first step, what we need to do is, this is step number 1. Alright. Step number 1 is, alright, since we need to list out the assumption here. The assumption here is the density of the flow is constant. Alright. Assumption where the first assumption, the density of the flow is constant. Alright. And second assumption is the velocity profile is uniform. Thus, we consider in the real case situation, we have the shear stress. The velocity profile is not uniform like this. So here we assume the velocity across this control volume is uniform. That means there is no shear at the wall, right? And based on the assumption given, the density is constant. Thus, we can use the continuity equation that derive from conservation of mass. So we can use the step number 2. We use the continuity equation, right? Using the continuity equation, which is A1 cross-sectional area 1 multiplied with velocity 1. Here is the average velocity equal to cross-sectional area 2 multiplied with velocity at the point number 2. And what is the area that we look at here? The area of the cross-sectional flow here. So in order to determine the area, we have to draw the eyes here. This is our eyes. What we look at the area here. The area is where the flow is perpendicular to the cross-sectional area. So you can see this is perpendicular. So when you look at here, the area is circle. So definitely we're going to use the area formula of the circle, pi d squared over 4 or pi r squared. Since the diameter is given, we can directly use the first formula. So just substitute the value of A1 V1 equal to A2 V2. So area here, number 1 is pi d1 squared over 4 multiply with velocity. This is average velocity at point number 1. Alright, equal to area at outlet number 2, which is the same, pi d2 squared over 4 multiply with average velocity at point number 2. And then we cancel out the same term, pi with pi, 4 with 4, and it leave only this term. Rearrange the equation, leave it the velocity to become the subject, because we need to find the velocity leaving the nozzle, which is this velocity. And then rearrange, become velocity 2 as the subject. The final equation is d1 over d2 bracket, because this is the power, the same power, we factorize the power of 2 multiply with velocity 1. And then step number 3, substitute the value. So velocity at point 2 leaving the nozzle is diameter 1, which is 100 mm. You can see here, you can convert to SI unit, which is meter. 1, 2, 3. It becomes 0.1 over diameter 2, which is 20 mm, convert to meter. 1, 2, 3, 0.02. Alright, so 0.02 bracket squared multiply with average velocity at point 1. Given here is 3 meter per second. So 3. Just using your calculator, the final answer is 75 meter per second. Next question asks the flow rate. The flow rate here is considered as the volume flow rate. So question number 2 is find the volume flow rate or flow rate. So using the formula flow rate, Q equal to A1 or V1 will be the same with cross-sectional area 2 multiply with velocity 2. If you use 1, use the velocity of 1. If you use area 2, use velocity at 2. The answer is the same. So let's use the first point. Alright, area 1, B1. And just substitute area is pi d1 squared over 4 multiply with velocity 1. So, pi diameter at point number 1 is 100 mm, convert to SI unit. Make sure use all your unit in SI unit. So, become 0.1 meter squared over 4 multiply with 3. So, using your calculator, you will get 0.1 squared divide with 4 multiply with pi. So you will get the final answer is 0.0236 meter cubic per second. Use your calculator and the final answer should be the correct unit. This is volume. So So volume flow rate meter cubic per second. Thus, that is the final answer.